Okay, hello everyone, and welcome to this FOSDEM 2021 OpenOffice UNO Programming with Groovy Talk. I'm Carl Markham. A little bit about me. I started off my career as a manufacturing engineer and machine designer. I started programming work by creating automation for 2D and 3D CAD applications. I currently work in engineering IT at Emerson Electric, doing automation work. And I also do freelance development as Code Builders LLC, mostly e-commerce applications, web apps using Grails, and I do OpenOffice automation. I've been an OpenOffice committer since the project was in incubation at Apache, and I'm a member of the project management committee. So the agenda for today, I'm going to do a high-level overview of UNO programming. Talk about the UNO libraries, a little bit about Apache Groovy and some advantages it provides. I'm going to go through an example of a single file client Groovy script that connects to and automates OpenOffice. Some of the OpenOffice Groovy projects that I've created, like the Groovy UNO Extension, which is a project that extends the Java UNO APIs with convenience methods to make the programming less verbose. Some command line project templates for creating client applications and OpenOffice extensions, and an example project of that. And the Groovy scripting extension that adds Groovy as a macro language to OpenOffice using the OpenOffice scripting framework. So what is OpenOffice? For those that don't know, OpenOffice is a fully functional office productivity suite that runs on all the major computer platforms in over 40 languages. So why would you want to use OpenOffice? So whether you're a government, a corporation, or a freelance developer, OpenOffice is attractive for many reasons. It's Apache 2 license, which is a very permissive open source license. Because it's open source, you can install it as many times as you like. It has a well-documented open architecture, and its extension mechanism and scripting framework allow extensive customizations and automation possibilities. So what is UNO? So UNO stands for Universal Network Objects. It's the core technology within OpenOffice. It provides client-server connections between different computer architectures and software languages. I look at it as the specifications and API for automating OpenOffice. So there's a software development kit available as a separate download. It contains documentation and examples of applications and extensions in Java, C++, OpenOffice Basic, .NET languages like C# and VB.NET, and a few examples in ActiveX and VBScript. So one of the things that brought me to the OpenOffice project was a plugin for the NetBeans IDE, which added wizards for creating OpenOffice UNO projects in Java using NetBeans. So it was included in the software grant to Apache from Oracle. And I had depended on this plugin to create client applications. So this gave me an opportunity to update the plugin for new versions of both OpenOffice and NetBeans. The plugin is current for OpenOffice. It's not up to date for NetBeans, but it does work with the current version. So looking to the future. There's many new tools and languages for application development these days. Where 10 years ago I was looking for a Java-based web framework to use for an e-commerce application. During that search I found Grails. It offers convention over configuration, and I could quickly get web applications up and running. So while I was using Grails, it used the Groovy language for the back-end controllers and services. So that's how I got started with Groovy, which I found to be a great language for all types of applications. It has a large ecosystem of projects around it, like the Gradle build tool, Spock and Geb for unit and functional testing, and Griffin for desktop applications, just to name a few. So what is Groovy? It's an optionally typed dynamic language for the JVM. What does that mean? Well, similar to Python, Groovy has the def keyword, which you can use when declaring a variable, and it will let the compiler decide the type. Or you can optionally declare the type yourself, or statically type it. So you can also statically compile Groovy for performance on par with Java. So Groovy can run 95% of Java code as is, and it integrates smoothly with any Java program and compiles to Java bytecode. So why Groovy? It has an easy to learn Java syntax. There's a large ecosystem around it, and you can use all of the available Java libraries. It has modern language features like closures and builders. There's API extensions using metaprogramming. I'm going to show an example of that in the Groovy UNO extension. It enables creating domain-specific languages like what is used by the Gradle build tool. And I have an example of a swing builder later on. And it's great for writing unit tests and build automation. So some things about Groovy and differences with Java. There's no need to use semicolons. Classes and methods are public by default. Properties are private fields and automatically get public getters and setters by default without needing to specify them. So what looks like a property like field access is actually using the getter and setter behind the scenes. Groovy has something called string interpolation, where you use G strings or Groovy strings, put the variable in line in the string instead of concatenating them together like you would in Java. Closures are reusable code blocks. This one example here is an inline example, but you could define the closure object and then reuse it also. There's no primitives, so a Java int here is actually the integer wrapper, and it just takes care of that automatically. Then the print line is short for the system out print line that you would see in Java. So now on to UNO. UNO has the concept of service managers, which are like factories for services. There's 5 primary services. There's desktop. I'd say that's the most often used. That's responsible for documents you open or a thing that you would put in frames or in a window. The configuration provider would be like things you would find in tools options. Database context handles databases. System shell execute is for executing shell commands. And global settings handles things like print settings. So services and interfaces. Services are the objects used to perform the work. However, when using the Java APIs, you have to use interfaces that provide the methods. So interfaces are not the same as Java interfaces. UNO interfaces are fine-grained implementation objects designed for reuse in the different applications. For instance, many applications use text. So text interface could be used in Calc or Writer. So instead of the Office document service shown here, we'll use Xmodel or Xstorable. And interfaces have an X prefix to distinguish them from services. So the spreadsheet document inherits from the Office document, and so inherits its interfaces as well. Unlike in Java, where we might use the new keyword to instantiate an object, in UNO we use a static UNO runtime query interface method to get the interface using the service object. So here's a first contact example from the developer guide, and it's also included in the SDK. I'll use this to illustrate the common steps in developing an UNO application. So getting a connection. We'll start by getting a component context. It's like the base object. We do this by using the Bootstrap method, which will start the Office if needed and make a socket connection and retrieve the context. I'm calling this a remote context because there's a local context on the Office or server side of the connection. So this is like a client-server connection. So now we get a service manager from the remote context. Again, this is our factory for creating services. Here's the desktop service we talked about earlier. Now we get one using the service manager. Earlier I mentioned we can't use the service directly in Java, so we're only typing it as an object type, but UNO will know what it is when we use it. Now we're going to get a component loader using the desktop service. The component loader is used to actually load the file. This is the first example of using the UNO runtime query interface method to get an interface using the service object reference. So here we're asking UNO to create an empty Calc document and load it. And now we're going to use the query interface method again to get the spreadsheet document. Now we can begin to work with the spreadsheet from here. And so this has been a high-level overview of the common steps in using Java for UNO applications. So let's talk about the Java UNO libraries. There are 4 main libraries that are divided up by their functionality. The one I want to point out is the UNO IL library, which is responsible for the spreadsheet document class, for example, that we just talked about. It's completely generated from IDL files, or interface definition language files, which are the specifications from which the different language APIs are created from. There are tools that come with the Office that you can use to generate Java classes from IDL files. This is also used by the NetBeans plugin and the command line templates I'll discuss later. So now we see where Groovy comes in. I'll show you how you can create how you can use Groovy to create a single file script client. Client here meaning a program that can remotely interact with OpenOffice. So one of the things that makes this possible is Groovy can be run as a script. So it will compile and run on the fly. So another thing is that Groovy has a built-in dependency manager. So similar to how you might declare dependencies in Maven or Gradle build file, we can do this in a Groovy script using the @grab annotation. And Groovy will put the jar file pull it from a remote repository and store it in a local cache and put it on the class path. The first one is a Bootstrap Connector, which is a special library that can bootstrap the Office using a file path to the Office. So in a traditional client application, this is done with different combinations of guessing based on what platform you're running on or searching the class paths for jars. So since we're using a single file, this is an easier approach. So the next 4 libraries there are my releases of the Java UNO libraries that I put in Maven Central. So they're not any different than what comes with the Office, except they can now be used by Maven, Gradle, and Groovy like any other library. It would pull down from Maven Central. And the last library is the Groovy UNO Extension. We'll discuss more in a minute. Now we'll look at some code that's very much like the Java first contact code we first saw. The only difference is it's in Groovy, so there's no semicolons, and there's also no need for typecasting when we use the query interface method, like when we're in Java. And the second example there is a much shorter version made possible by the Groovy UNO Extension library, which is the topic of the next talk. So the Groovy UNO extension uses a feature called extension modules in Groovy to add methods to existing classes at runtime using metaprogramming. In this case, the Java UNO APIs. In this example, we create an extension class named Spreadsheet Extension and add a method that we want to include in the API. The first argument in the method is actually the class that will get the new method and every class that inherits from it. So then Groovy will instrument the classes at runtime and make the method available. So basically the goal of the Groovy UNO extension is to increase developer productivity by making the code less verbose. Initial work's been done on the spreadsheet development since that's what I do the most of. And we'll look at some examples. So the first thing is replacing the query interface method, that static method that we keep seeing. Here you can see we've replaced the static UNO runtime query interface method that takes the return object class and the from object as arguments and replaced it with an instance method called GUNO on the from object that takes only one argument, the class, object class that we're requesting. So it hasn't reduced the number of lines, but it's definitely reduced the amount of text. So another common task in UNO is property access. In this example, we're getting a spreadsheet cells style. In UNO, this is done using a property set object. In Java, we use the set property value method of property set. In our extension, we've added a getAt and putAt method, which are special names in Groovy that now allow for map or collection-like access using what's called Groovy's subscript operator, as shown on the last line. Cell content. So that's another thing we do a lot. We've added 4 convenience methods to cell range, which includes the spreadsheet class also that inherits it. So these methods allow access based on a column and a row coordinate. So in Java, we had to use the spreadsheet to get the cell range, to get the text, to set the string. Now we can do all this in one line. So I won't go through this line by line. It's just to illustrate a larger example. So the example is to create a cell range container, add all the cells that have content, and then iterate through them. And so you can see just doing that, that's quite a bit of code. So by adding 2 methods to the extension, we've reduced the code by more than half. So some of that is from the new methods, and then some is from using a Groovy closure that I talked about earlier to iterate the cell list instead of needing to get the UNO enumeration object used to iterate with in Java. So it's really a team effort between Groovy and the extension that allow for this. So another common task is displaying message boxes. So this is the code required to display a simple message box in Java. So one simple box and all this code. So by adding one method, we can reduce it to this. Now it's more like it. So in a little bit more complicated example, this is a warning box with a custom title and configurable buttons. and it's just a little bit more code. So while not part of the extension, this is an example of what Groovy brings to UNO programming. So for those not familiar with Java programming, Swing is the name of the second generation UI toolkit, which came after AWT. Swing can be quite verbose, and Groovy includes a DSL for building Swing UIs, and also includes help with common threading problems encountered by incorrect usage of the event dispatch thread. So UNO project templates. So project templates are used to generate UNO applications or extensions for OpenOffice. There's three main types. There's client applications. So this would be standalone applications that can bootstrap the Office and interact with it. Then there's Calc add-ins, which these add custom functions to the spreadsheet application. And then there's add-ons, which are just general purpose extensions for adding functionality into any of the Office applications. New toolbars, buttons, commands, things like that. So talked earlier about the NetBeans plugin. One thing about it is it only creates Java projects that build with Ant, and can only be created using the NetBeans IDE. So a few things about that I wanted to do differently on this project. One was get out of IDE lock-in and build something I could use to create UNO projects that use other build tools like Maven and Gradle and new languages like Groovy. So I decided to base them on a project called Lazybones. So Lazybones is a command line project creation tool written in Groovy. And currently we have two Calc add-in templates in the project, both Gradle build with one's Java and one's Groovy. And then we have a Gradle built client application also. So the add-on templates are coming soon, but not yet available. So before I start into this, I just want to mention that at the end of the talk, there's going to be a page of links for all of these projects, and there's also instructions on how to get Lazybones installed. It's pretty easy if you're on any of the Unix, Linux type platforms using SDK man. So Lazybones templates use variables. So when you put your template projects, create your template projects, you use variables throughout that Lazybones will take care of swapping out for what you tell it to use when you create the project. So things like package name, project name, it will rename some of the files based on the project name that you give it, things like that. So the example I'm going to show, this is actually a real life example from some spreadsheet work I was doing, and I needed to break up file path strings into the component parts, path, base name, extension. So the paths were a mix of Unix and Windows file paths. Some of the file names had multiple periods within them, not just for where the extension was. So after spending a few hours on the formulas that I ended up, it would work for tens of thousands of these file paths, there were still a few corner cases that didn't work quite right. So in Java programming, I would use something like the Apache Commons IO file name utils for something like this. So I decided to make a Calc add-in extension based on that, using and creating the three methods for doing that. And after using this project creation tool, it takes about 15 minutes to do something like that. So it's saved me quite a bit of work. Also, this is on GitHub too if you want to take a look at it. So here's the command line that would be used for creating this. It's a Lazybones create AOO add-in and a version 030, and the name given was FileUtils add-in. So then it will prompt you for package name, things like that. And then Lazybones will go ahead and pull a template down from Bentray and output you the README file on the command line, and also display the project structure so you can see where all the files are and some instructions on what you might want to update. But it is a buildable working extension right out of the gate. So I'll just step through the steps needed to do this. The build Gradle file, we would add the Commons IO library to the dependency block. We have an IDL file where we describe the interface definitions for the 3 functions we're going to create. Then we actually have the implementation Groovy script. So this is the actual code for the functions that we're adding. So we would import in the file name utils and then add a method implementation for each function. So there's an XML file that describes the functions to Calc, and we would copy the example block and edit it for each of the function names and descriptions. So then there's a description XML file that describes the extension to the extension manager in OpenOffice. So we would edit the display names, the icons, and put the localization text in. So depending on what language you're using, you can have different descriptions that you would see in the extension manager. So then that's all, and then we can build the extension using a Gradle, and then Gradle has great support for the ant tasks. So all of the ant tasks that were coming from that were used in like the NetBeans plugin, I've copied over into these projects, and then Gradle calls these ant tasks. So there's in the NetBeans plugin, there's a couple thousand lines of ant code. So I don't want to recreate that in Gradle just to make it a Gradle project. So luckily Gradle supports that. And it compiles the 2 jar files, one of them being the IDL files, and then the other is the Groovy scripts. And then packages all those up into the OXT file, which is our extension. So then we would use the OpenOffice Extension Manager to import in the OXT file, and then you can see the descriptions and titles, logos, and things like that we described in the XML. And then would restart the Office usually after installing an extension, and then it's ready to go. So the last topic is Groovy macros in OpenOffice. So the Groovy scripting extension uses the scripting framework in OpenOffice to add Groovy as a macro language. So starting with the built-in bean shell example that's in OpenOffice, I modified it for Groovy, and then use the Groovy shell class in Groovy to evaluate the macros. So it uses the same simple editor in OpenOffice that is used by the bean shell macros. So it's a pretty simple editor, so I generally code in an IDE and then copy and paste it into the editor as I work. So to get started, you use the extension manager to install the extension. And after restart of OpenOffice, you'll see Groovy available in the macro menus. So then you can create a new library and a new Groovy macro. One thing I'll note is the Groovy macros already include the Groovy UNO extension we talked about earlier, and it's a running hello world macro. So it's the template is already a running macro. So and it's full of links and references to documentation, things like that for new users. So one advantage that macros have over client applications is you don't need to bootstrap the Office. You start off with a reference to what's called a script context, which is similar to the remote context we had to get through bootstrapping the Office in the earlier example. So I'll just run through this. You get the model, then get the text document, then all of the document's text. Then we set the text range to the end, and then we finally set the text. So really you're just following the object tree down from the application to the document to the text. So sample macros. So this final extension is for sample macros. So OpenOffice comes with sample macros in OpenOffice Basic, Python, Bean Shell, JavaScript. So I've rewritten the Bean Shell and JavaScript macros in Groovy and included them in an extension that you can install. But one thing about using it this way is the macros are packed in the OXT file and you can't edit them. So if you want to play around with the code, I recommend just going and copying and pasting the text from the GitHub project into your own macros. So in summary, if you're interested in OpenOffice development, come join us on the developer mailing list. If you're interested in any of these Groovy projects, you can fork them on GitHub, and I'd love to collaborate with you about them. So a rising tide lifts all boats, so to speak. So I'd love to see people get more involved in both projects. So I'll go ahead and show the links. And I really appreciate you taking the time to attend the talk, and I hope you enjoy the rest of the conference. And now I'll take time for questions.